This is going to be a short presentation of how Militec1 synthetic metal conditioner works on the metal surfaces. Right here, simple testing equipment, little kind of thing resembling a oil pan, synthetic oil, 10W30, full synthetic. I'll be adding a little bit here, just enough to dip in that roller to get a little bit coating on the parts, just like we have in a combustion engine on any other mechanism. Mounted right here is a ball bearing ball, very small one. I preheated this with the heat gun, so right now the temperature of that ball is 125 degrees Fahrenheit. It will increase, and actually I would like to increase it even further. Normal working temperature in a case of a car engine is around 177 degree Fahrenheit, equivalent of 80 Celsius, and that is considered to be optimal safe temperature range. So what I'm trying to do here is to mimic this kind of situation. I actually exceeded 190, 180, depending on where I'm putting a thermometer. We got 162 Fahrenheit. We'll be adding a little bit pressure here, just to simulate the situation of, let's say that we have brand new engine, and at first that engine requires a little breaking in process. Whoever have, let's say, chainsaw, we know that there is a break in oil required at first, so let's kind of break it in for a minute by just pressurizing it gently, maybe in the range of about 5 to 10 pounds of pressure for a minute. Problem navigating with that with just one hand. So right now I'm running this for 48 seconds. Let's give it a little bit more time. I'm kind of moderating our pressure from between 5-10 to maybe 15 pounds on occasion, lightly. Check the temperature. Okay, the frictional point is 180 Fahrenheit at the moment, which is 82 Celsius. That's ideal temperature, really. Time 1.5 minutes so far. The oil became a little bit slightly darker. So at 2 minutes I will be pressing in an increments of about 10 pounds at the time, right now. 50, okay, 60 pounds, and let's call it game over, right? At 60 pounds, protection of that oil has been destroyed, eliminated. So now, wow, this is really hot. Yeah, the temperature of this is 175 degrees. That's kind of unfriendly to the bare skin. I'd like to remove this and recondition that roller surface, as it has been damaged by friction, and it's hard to see to the naked eye the damage on the ball, but this ball has been damaged. It is tiny damage, but good enough, well, to kind of poor lighting. I don't know what's visible, but yeah, this is definitely flattened here. So my next step is to replace the ball and choose different friction point of contact between those two, and to recondition a little bit to the previous stage that roller by using a 220 grade sandpaper. Actually this is 120. That surface has been made kind of roughed up by what just happened. So nothing scientific here. This is not like I have some sophisticated equipment that can give me assurance that each time I have repeatable environment for that experiment. Simple test, visible to the naked eye. I mean, if someone can afford that, you guys feel free to fill up the engine with a brand new oil, drive 200 miles, then drain it, see what happens, how far can you get, and then change the engine and use the other one with the same oil, plus add some 2 ounces per each quart of oil. Militec proportion, 2 ounces per quart of oil. That's the proportion that is suggested to use with the engines. Okay, and so that is smoothed out right now. And I have also super fine 600 grid. Okay, that roller is super hot right now still. The temperature of it, oops, wrong tool, sorry. The temperature of that roller is 109 degrees. I will be returning the previous oil, which at the moment contains a little bit of metal particles generated during previous situation. Now, this is the Militec one here. There is everyone can see how little it is, right? So I will be adding this into the equation. Okay. It's recommended then that in a situation of a vehicle, car engine, you add 2 ounces of Militec1 per each quart of primary lubricant. You're supposed to add, let's measure the time, you're supposed to add 4 ounces in total to average car engine, vehicle, passenger car transmission, automatic transmission. And you can go online and find proportions and suggested quantities that you're supposed to be using with particular application. Boosting the temperature right here again by using the heat gun, and also again I'm going through that process, let's call it breaking in again. So those rubbing surfaces at first have to be allowed to undergo through some simulated process of breaking in with moderate pressure added to them. Check what the temperature is, but if anyone pays attention right now, that's the temperature, 183, 84 Celsius. So actually at this point I have maybe 2 degrees higher temperature than previously, which in case of an oil, the higher it goes, the thinner it gets. It means the less lubrication and protective properties oil will have. So we may call it even slightly at a disadvantage position versus previous. That's if someone wants to pay attention to the really details closely. So yeah, 190. Okay, I take it. So it's 2 minutes 8 seconds so far. And if you guys need to rewind, please pay attention to that sound, what just happens over time when Militec is added, how that rubbing kind of abrasive sound changes, showing that actually friction has been reduced. So the next step is to apply similar pressure. The light is really poor, I'm so sorry here. But yeah, 10 pounds at the time. This is now at around 20 pounds. 50 now. Okay. So this is 60 pounds. 60 pounds right now. So at 60 pounds, synthetic oil wasn't capable of providing a separation between those two metal surfaces. Clearly, this ball wants to stop that roller from spinning. Now, 60 pounds is not doing it. Let's see how long that 60 pounds actually can take us. So right now I'm pressing at 60 pounds, foot-pounds, in between those 2 points, which with just Castro full synthetic and WD-30 lasted very short moment. I wasn't timing exactly, but everyone feel free to look at the timing for yourself. This is a while right now. So I started pressing at 2 minutes down into that. Now we're looking here at almost 5 minutes of 60 pounds, foot-pounds of pressure between the surfaces, and mechanism is still operational. There is still lubrication provided adequate enough for this thing to operate. pressure, 290. Fahrenheit. That's my highest reading here. 313, which is a 156 Celsius temperature, continuous close to 80 pounds. So I will be elevating this, boosting the pressure up to 100 pounds. This is 100 pounds of pressure. Right now it's 100 pounds, 100 pounds. Oil is clearly smoking. Temperature 159 Celsius, 300, almost 40. Wow, that's crazy. 336 Fahrenheit, right? You cook a pizza in your oven, you can bake a pizza at this time, at this point. Pounds right now, the pressure, 100 pounds, 100 pounds right here, right? Okay, because the light is kind of poor, so this was showing right here, 100 pounds, right? Let's see again temperature. It's cooling off, 304. Even this is super hot.